And I have some wood ash here at the base of the fire. So this is just ash that's been thoroughly burnt. And the wood itself, the plant matter, contains potassium. And as it burns, it combines with the carbon that's in the wood and some oxygen here, forms potassium carbonate. So this wood ash used to be called potash. Okay? It was called potash from the pots that they used to extract this. In fact, if we have a look at the next slide here, we see some pots that they are putting the ash into and extracting the potash from this. And the potash is actually just potassium carbonate. Right, I'm going to light my candle. Right, my candle's burning nicely. The ash here contains potash or potassium carbonate. Adding acid, and the acid that I'm using is just vinegar, adding acid to the carbonate generates carbon dioxide gas, so we can see the bubbles here. And the carbon dioxide gas is heavier than air, and it's gradually filling up the beaker, and it's now extinguished the candle. So that was the carbon dioxide formed from the reaction between the potassium carbonate and the acid. Well, actually, I've said that potash gets its name from these pots that they used to put the ash into, potash. In fact, this also gives rise to the name potassium. So the pot in potassium comes from these pots here. Well, how can you make potassium from this ash? Well, as a cunning reaction, we take our potassium carbonate and add it to some calcium hydroxide. These are all in solutions. So I've got some solutions here. So we've got our potassium carbonate. So that goes in here. This is from our potash. And I've got a solution here of the calcium hydroxide. Remember, that's what we made from the stone, heating up the calcium carbonate and driving out the carbon dioxide. We've got calcium oxide, then add water to it, we end up with calcium hydroxide. Well, here's a solution of that. And the clever thing is, when you mix these two things together, okay, you get a milky colour here. The white colour that you see here is calcium carbonate. It reforms. So what happens, these things, let me see if I can get this, swap round like that. Okay, and we end up with calcium carbonate. That's the white colour that you see. And in solution, we have potassium hydroxide. And this was called caustic potash. Okay, and it was this that was first used to isolate potassium metal. And this was done by, well, this is the reaction that we've just seen there. The calcium hydroxide reacting with the potassium carbonate to form calcium carbonate. That's the white colour, the insoluble chalk, and forming potassium hydroxide. But it was the potassium hydroxide that was first used by this chap, Humphrey Davy, in 1807, and he isolated potassium metal. He did this by melting the potassium hydroxide and passing an electric current through it, and this is his description of his production of potassium here. Okay. And it says in this, there is a body usually called potash, or the vegetable alkali, which may be procured thus. Quicklime, which we've seen is the calcium hydroxide, is mixed with a solution of wood ash, just as we've been doing here, to liberate our potassium hydroxide, blah, blah, blah. He then passes an electric current through this, but of course there was no electricity in 1807, so he had to use a very primitive apparatus called a voltaic pile, and this consists of a series of zinc and copper plates here, different metals stacked together, okay? And this generated enough electric current to enable him to separate his potassium hydroxide and liberate potassium metal.